all, so the normal is like this. If at all the normal is like this, then the reflected ray will be in this direction. When this is the angle of incidence beta, this is the angle of reflection, which is beta. Okay, so if at all you extend this thing over here, this will be the deviation, which is in the anti-clockwise direction. So this is the deviation delta 2, you say. So in this case, delta 2 is equal to 180 minus 2 beta. 180 minus 2 beta, right? Now, total deviation you need to talk about, which is delta 1 plus delta 2. So delta is equal to, so this becomes delta 1. So that is minus 180 plus 2 alpha. Delta 2 plus 180 minus 2 beta. So these two things will get cancelled out. Therefore, the total deviation, that is 2 into alpha minus beta. 2 into alpha minus beta. Now, what is alpha minus beta? This is what we have to think of now. So look at this. When this is alpha, this particular angle will become 90 minus alpha. Now look at this. This is the normal. This is the normal. Understand? Okay. So that's here. So this is here. What is the normal over here? Normal is from here to here. Okay. This is the third angle of the triangle. Up to here. From here to here, 90 plus beta. That particular angle becomes the 90 plus beta. Okay, so by angle sum property, so theta plus 90 minus alpha plus 90 plus beta. Are you clear with this? Are you clear with that? 90 plus beta. Okay, so that is equal to 180. So 90, 180. Okay, so theta. So the second you see minus alpha minus beta is equal to 0. So theta is equal to alpha minus beta. Right? Therefore, delta is equal to 2 into theta. Therefore, delta is equal to 2 into theta. Like that. So this is the general discussion. Okay. Now, the means when the combination of mirrors is given, whether you are going to use the formula of 1 so 360 minus 2 theta or 2 theta, that completely depends upon the directions of deviation angles. But again, so go for 360 minus 2 theta when both the angles of deviations are in the same direction. Go for the formula that is delta is equal to 2 theta when the angles of deviations are in the opposite directions. So that is a clarity I wanted to give you this morning. I have given, right? Okay, now this is how the reflection by plane mirrors takes place. Reflection by plane mirrors takes place, right? Okay, now we will be discussing about the reflection by spherical mirrors. Reflection by spherical mirrors. Okay, what do you mean by spherical mirror? This is what we need to think of now. What do you mean by spherical mirror? What do you mean by spherical mirror? What do you mean by spherical mirror? So what do you mean by spherical mirror? It's a part of a sphere that becomes a spherical mirror. So look at this. If you take any sphere like this, okay, some portion has to be cut from this. This portion has to be separated aside like this. Okay, now this is pure transparent. Now we need to apply silver coating. And if at all you apply silver coating on the exterior portion, then the reflecting surface is inside one. Okay, so this is a reflecting surface. This is a reflecting surface. This is a reflecting surface. Okay, now if at all you just extend this thing, this sphere you will get. To that sphere there will be some center, which is called center of curvature. So this becomes the center of curvature. This becomes the center of curvature. But okay, now this is the center of this particular portion. So this is the pole. Now is it concave or convex? That depends upon That depends upon the reflecting surface. When the reflecting surface is towards the center of curvature, the mirror is concave. When the reflecting surface is away from the center of curvature, on the other side of center of curvature, then it becomes convex. So in what way? So look at this here. You see, this is that okay curvature I have taken. Now, okay, on the interior part, I will be applying the silver coating. Silver coating is applied over here. Then the exterior part becomes a reflecting surface. Then the exterior part becomes a reflecting surface. The exterior part becomes a reflecting surface. But where is the center of curvature? The center of curvature you will be obtaining when you extend this portion. So this becomes the center of curvature. So when the reflecting surface is away from the center of curvature, so this mirror is convex. When the reflecting surface is towards the center of curvature, this mirror is concave. This mirror is concave. Got it? Okay. Now, in the case of concave and convex, some of the things we have to keep in mind. So, what are they? Some definitions. All those definitions you are aware of. Even then, just for revision's sake, I am recalling. Suppose you take concave mirror over here like this, and the exterior portion is coated with silver paint. Okay. Now, if at all you extend this, okay. So there will be some center which is called center of curvature. There will be one midpoint over here which is called pole of the mirror. So this is the pole of the mirror. Okay, now this is different. You just join these two things, then you will be getting the radius of curvature. The radius of curvature, and if you extend this radius of curvature on either sides, then you will be getting the principal axis. Then you will be getting the principal axis. Got it? Okay. Now, if at all a parallel beam of light is incident on this light ray undergoes reflection. Like this, you can take as many light rays as possible. After reflection, all these light rays will be just passing through a particular point. That point is nothing but focus. That point is nothing but focus. Principal focus also we can see. Right? The distance between the center of curvature and the pole, this can be taken as the radius of curvature, whereas the distance between the pole and the focus, this becomes a focal. This becomes a focal length. Understood? So what is the relation between the focal length and the radius of curvature? So focal length is half of the radius of curvature in the case of mirror. When it comes to the lens, it will be different. That will be different. Okay, so what about the equation F is equal to R by 2? I have written that is applicable only for mirrors. Only for mirrors. Right? Now coming to so the image formation by these mirrors, all the things you are aware of, I need not write. But I will tell orally. So there's again different you take object which is so far away, which we call as infinity. When the object is at infinity, where will the image get formed? The image gets formed at the focus, which is real, inverted, and highly diminished, very small. The ray diagram are the things you practice once. Got it? Okay. When the object is beyond the center of curvature, where will the image get formed? Image is between the focus and the center of curvature, which is real, inverted, and diminished. Not highly diminished, but diminished. Correct? Highly diminished means point size. Okay. When the object is at the center of curvature, then where will the image get formed? At the same point, which is center of curvature, which is real, inverted, and of same size. When the object is between the center of curvature and focus, image will get formed beyond the center of curvature, which is real, inverted, and enlarged, which is magnified. When the object is at the focus, the image is formed at infinity, which is real, inverted, and highly magnified. Highly magnified. Okay, when the object is between the focus and the pole, the image is formed on the other side of the mirror, which is virtual, erect, and enlarged. Which is virtual, erect, and enlarged. Okay, so these are the image formations by a concave mirror, different cases. Okay, so coming to convex mirror, in the case of convex mirror, okay, so we don't come across all the situations, only two situations we come across. One is when the object is at infinity, and the other one is when the object is at a finite distance. When the object is at infinity, what kind of image will get formed? Virtual image formed at focus, okay, which is erect and highly diminished. Understand? Highly diminished. Okay, when the object is at a finite distance, then where will the image get formed? Between the focus and the pole. Between the focus and the pole. Okay, so in this regard, one theoretical applicative question can be asked. In the case of concave mirror, yes, the object is moved away from the mirror, how will the image move? Towards the focus. Towards the focus, because when the object is at infinity, its image is getting formed at the focus, which is virtual, erect, and highly diminished. Understood? Okay. Yes, the object is moved away from the mirror. Okay, the image will be moving towards the focus. The image will be moving towards the focus. Hold. Yes, the object is moved away from the mirror. How will the image move? Towards focus or towards polar? Towards the focus. Convex. Convex, dear. Concave, I said. So in the case of concave, what happens? Towards polar. Even in the case of concave mirror, you take, yes, the object is moved away from the mirror. How will the image move? Towards focus. When the object is at infinity, where will the image get formed? Focus. You are moving away from the mirror. Away from the mirror. You are approaching the infinity. You are approaching the infinity. Are you getting my point? Okay. When the object is exactly at infinity, the image will be at a focus. You are moving away from the mirror, not towards the mirror. Away from the mirror. Then what happens? Image will be moving towards the focus. Clear? Sachin? Clear? Still doubt? Still doubt? Tell me, yeah? Doubt or clear? Okay. Right? Okay. Towards the focus. Towards the focus. Okay. So this type of applicative, theoretical questions will be asked. Okay. Now to answer those questions, ray diagrams you have practiced. Now I am not drawing because it takes much time waste. You practice. You observe while drawing the ray diagram how the image is obtained. How the image is obtained. The fellow is not still clear, not convinced. Hello, Arjun. Look at the board. So this is a concave mirror. Okay, so this is a focus. This is pole. This is center of curvature. Understood? Center of curvature. Okay, so as the object is okay, so it's kept at infinity, then the image is exactly in the focus. Am I correct? Yes or no? Yes or no? Away from the mirror means what's the meaning? If at all you place the object over here only image is formed. If the object is kept beyond the center of curvature, image is in between this. From center of curvature, image is moving this. Okay, further you move. Further it moves. Further you move. Further it moves towards the focus. Keep it at infinity. Infinity. focus, the image is formed. That's all. Focus is the endpoint. Okay, in the case of this concave mirror, will you get any image between the focus and the pole? If at all you place object over here the image is formed, which is a virtual. Are you getting my point? Okay, this is the last case, which is different. Okay, case number 1 to case number 5. What do you notice? What do you notice? You are coming from infinity towards the focus. Not pole. From infinity towards focus. Now do you understand? Okay, so this type of technical questions, there's a logical thinking. On the spot, you should be able to think of, otherwise the rough diagram you have to draw and you have to give the correct answer. Understood? Like this. Okay, so this is something about concave and convex mirrors, image formations. Image formations, right? Even in the case of convex mirror, also same thing happens. As the object is moved away from the convex mirror, image will be moving towards the focus. When the object is at infinity, ultimately image will be at the focus only. Even in the case of convex mirror, image will be at the focus. Okay, like this. Okay, the next concept is mirror formula. So what is mirror formula? Mirror formula. Mirror formula. Mirror formula is nothing but 1 by f is equal to 1 by v plus 1 by u. Where f stands for focal length and u stands for object distance, v stands for image distance, and v stands for image distance. Image distance. Okay. Now coming to one more thing over here, look at this. Magnification we need to discuss. We need to discuss something about magnification. So what do you mean by magnification? This is what we have to think of. This is what we have to think of. Magnification. What do you mean by magnification? It is the ratio of height of the image and the height of the object. In that way, we can tell m is the symbolic representation of magnification. So the ratio of height of image and height of object. So if you take that becomes magnification. That becomes magnification. Okay, so this magnification can also be written as the object. So image distance divided by object distance. Got it? Negative. M is equal to minus v by u is the magnification in the case of mirror. Magnification m is equal to hi by ho. This is the magnification in terms of image height and object height. Image height and object height. Okay, so there are 5 things I told which we will be obeying, which we will be following while solving the problems. What are they? The very first point is if at all in any situation magnification is positive. So what's the conclusion? Image is virtual and erect. Okay, so this tells us image is virtual and erect. Image is virtual and erect. Image is virtual and erect if magnification is positive. Okay, so in any problem, so if at all you get magnification as a negative value, but in this case, is image magnified? Is image diminished? Is image of same size? That information is not there. That information is not there. Whenever you get positive magnification, only one conclusion we have to make over there. But is that the image is virtual and erect. Next, if at all magnification is negative, so what information will you be getting over here? Image is real and inverted. Real and inverted. This is what when the magnification is negative. So the third one is sometimes you will be getting magnification 1. If at all magnification is equal to 1. So what information will be you getting? The size of the image is equal to size of the object. Okay, size of the image. The size of the image is equal to the size of object. Size of the object. This is what we can understand. Size of the object. Size of the object. Okay, so if you know the magnification is more than 1, if you know the magnification value more than 1 in any situation, in any problem, so what do we get by means of this? The image, okay, is enlarged, means magnified. The image is enlarged or magnified. The image is enlarged or magnified. So when magnification then is greater than 1. And the fifth one, so when magnification is less than 1, so then what do you say? So the image is diminished. The image is smaller. So which is diminished. Okay, so this is the information that we get. Okay, this is the information that we get. Understand? Like this. Okay, now coming to the sum. About mirrors, this is on spherical mirrors. Now coming to the second property of light, which is refraction. Huh? Mirror formula already I have to know 1 by f is equal to 1 by v plus 1 by u. Sleeping? What yeah, Mayo? You didn't write. 1 by f is equal to 1 by v plus 1 by u. Mirror formula. After mirror formula only we do this magnification. After mirror formula only we do this magnification. Okay. Next property, that is refraction of light. Next property is refraction of light. What do you mean by refraction? In fact, refraction is a big concept. Okay, reflection is a small one, right? But refraction has many cases. Okay, so refraction. What do you mean by refraction over here? What do you mean by refraction? Refraction is a phenomenon in which light undergoes bending effect when it passes from one medium to the other. But what about the combination of media you are going to take up? The media means plural of medium. Mediums becomes media. Okay, so what about the two media? We say we take those two media must have different densities. Okay, in those different densities, the medium whose density is lesser denser medium or rarer medium. Less denser medium or rarer medium. And the medium whose density is more denser medium or simply denser medium. Okay, now I will be taking one situation over here. Look at this. This I am taking as air, this I am taking as gas. And if at all you compare the densities of these two media, air and glass, air density is less and glass density is more. So for us in this combination, air becomes a rarer medium. Air becomes a rarer medium and glass becomes a denser medium. And glass becomes a denser medium. Air becomes a rarer medium and glass becomes a denser medium. Denser medium. Okay, I will be taking one source of light over here. A light ray is passing in this direction. If at all you draw a perpendicular, which you are calling as normal, the angle between the incident ray to the normal is nothing but the angle of incidence. The light ray is supposed to travel like this. This must have been the actual propagation of light ray. But the light ray exhibits a bending effect. Okay, so in what way? Yes, the light ray passes from rarer to denser towards the normal. Light ray will be bending. So the bending of light will be like this. Okay, so from the usual propagation, light ray is exhibiting some deviation. The deviation exhibited by the light ray. So this becomes the angle of deviation. The angle of deviation. The angle between the refracted ray from the normal, this can be taken as the angle of refraction. Okay, so this angle of deviation we have to write. How do you write angle of deviation in this particular case? Look at this. This is one line. This becomes one more line. This is the angle of incidence. Then what do you say about this? Even this thing also becomes the angle of incidence I. Right? Okay. So I in this particular case is equal to R plus delta. So angle of deviation is equal to I minus R. So this is the formula that we are going to use when the light ray passes from rarer to denser to get the angle of deviation. Same thing when the light ray passes from denser to rarer. I will be showing that situation here. Look at this. This is air, which is a rarer medium, and this is glass, which is a denser medium. I am taking the source of light here. The light ray is passing in this direction. If I draw one perpendicular, which you are calling as normal, the angle between the incident ray to the normal is the angle of incidence. The light ray will be passing away from the normal like this. Away from the normal. Okay. Now the actual propagation of light ray is this. From the usual propagation, light ray undergoes a deviation in this direction. The angle between the refracted ray from the normal. So this is the angle of refraction. When this is the angle of incidence, what will be this angle? Even this angle becomes the angle of incidence. Even that angle becomes the angle of incidence. Now, I plus delta in this particular case is equal to the angle R. Therefore, delta, which is the angle of deviation, R minus I. R minus I. R minus I. Okay. So that is the angle of deviation in this case. But sometimes in the nature, we come across the situations in which light ray is incident on the refracting surface normally, means perpendicularly. Normal incidence we call. This can be taken as the third situation. Normal incidence. Normal incidence. Okay, so now this is normal incidence over here. That is normal incidence over here. In this direction, light ray is passing. What happens? There will be no deviation. The light ray never shows any deviation. So what do you say about the angle of incidence? What do you say about angle of refraction? What do you say about the angle of deviation? But again, so that is the third situation. That is the third situation. But again, okay. Now coming to one more thing. When the light ray passes from denser to rarer, we come across one important situation. One important situation. What is that? Critical angle and total internal reflection. Critical angle and total internal reflection. Okay. But before that, let me speak something about refractive index. Because the critical angle in the sense we will be handling with the refractive index. Okay, so refractive index. Keep the heading. Refractive index. Refractive index. The symbolic representation of this refractive index is mu. The symbolic representation of this refractive index is mu. Okay, so what do you mean by refractive index? See, that is the characteristic property in which light ray bends during the reflection. At what level, at what angle the light ray undergoes bending, that is called a refractive. That's a refractive index. The refractive index is decided by denser medium's density only, mainly. If the denser medium is more denser, we say refractive index is more. If denser medium's density is less, we say refractive index is less. Okay, so look at this here. You see, the refractive index of water with respect to air is 4/3. refractive index of glass with respect to air is 3/2. So which is more, which is smaller? Okay, 4/3 means there is 1.33. 3/2 means 1.5. Which is less, which is more? This is more. So refractive index of glass with respect to air is more than refractive index of water with respect to air. Understood? That means what do you say here? Glass, water. When you compare these two media, usually the density of glass is more than that of density of water. That means if you send a light ray, get equal angles of incidence into water, into glass, in which medium, water and glass, the bending will be more. Through glass, bending will be more. Through glass, bending will be more. Through water, bending will be less. Through water, bending will be less. Okay, because the water is less denser. Glass is more denser. Both are denser media. Both are denser media. For both the worlds, of air is a rarer medium. Understood? Even if both are denser media, okay, so when you compare the densities of these two media, there is a difference. Glass is more denser, water is less denser. Both are denser media. Try to understand my language. Got it? Okay, so therefore, when you send a light ray, get equal angles of incidence through water, through glass. Through glass, bending will be more. Through water, bending will be less. That's what we have to keep in mind. Okay, like this. So this is something about the refractive index concept. Now, how to measure this refractive index? Okay, while solving the problems. Now, look at this. Here you see some air, and this is glass I am taking. Okay, light ray is passing over here. This is the normal. Okay, yes, the light ray passes from air to glass. Light ray undergoes refraction, which is towards the normal. This becomes the angle of incidence I. This becomes the angle of refraction R. Now, if at all you take the ratio of sine of angle of incidence and sine of angle of refraction, so that is nothing but refractive index of glass in this case with respect to air. With respect to air. Okay. Right? I told you a small technique. What is that? The refractive index mu, if at all you write it, so which medium's refractive index will you get? The medium which is opposite to the angle of incidence. The medium which is opposite to I. I means the angle of incidence. That medium's refractive index will get. That medium's refractive index you will get. But so that is called, okay, so this is cyanide by cyanide, which is called mu g. Mu means that there's a refractive index of glass with respect to air. So this is called Snell's law. This is called Snell's law. Snell, he was a scientist. So Snell's law, we say, this is Snell's law. This is Snell's law. Snell's law. Okay, cyanide by cyanide. Cyanide by cyanide. Okay, like this. Now, based on this, one more thing that we will keep in mind. What is that? Principle of reversibility. Did anyone remember? What do you mean by principle of reversibility? Principle of reversibility. Principle of reversibility. Reversibility. So what do you mean by principle of reversibility? Principle of reversibility. Yes, Sagari, what is something? Refractive index of glass with respect to air is equal to the reciprocal of refractive index of air. Refractive index of glass with respect to air is equal to refractive 1 by refractive index of air with respect to glass. refractive index of light with respect to glass. So that is called principle of reversibility. That is called principle of reversibility. Okay, now this principle of reversibility we will be using while writing critical angle and the radar. Okay, so now critical angle. Critical angle. So what do you mean by critical angle? This is not really clear now. So it is symbolically represented by the letter C. It is symbolically represented by the letter C. Okay, so what do you mean by critical angle? There is a condition to have this critical angle. So what will be the condition? The light ray propagation must be from denser medium to rarer medium. The light ray propagation must be from denser medium to rarer medium. Okay, when the light ray undergoes refraction from denser to rarer, the refracted ray will be moving away from the normal. Okay, so different situations I will be showing over here. So look at this. Here you see this is air I am taking, and this is glass I am taking over here. Right? And if at all you take a source of light in this. Right? Now, so this here, if at all you take one normal incidence over here. So this is the normal incidence. Normal incidence. Then without having any deviation, the light ray will be just passing through like this. The light ray will be just passing through without having any deviation. Normal incidence. And if at all the light ray undergoes a reflection, which is a refraction, which is oblique incidence, then what happens? So this becomes normal, right? The light ray will be moving away from the normal. The light ray will be moving away from the normal. And if at all the light ray passes a refraction, further away, so then what happens over here? The light ray will be just moving like this further away. Okay, so yes, you keep on increasing the angle of incidence. Here, the angle of incidence is 0. Here, the angle of incidence I1. Here, the angle of incidence I2. So it's very clear. I2 is greater than I1. I2 is greater than I1. Okay, so like this, you keep on increasing the angle of incidence. Then the angle of refraction will be increasing. Means the refracted ray will be moving away, further away from the normal. Like that, for a particular angle of incidence. So what happens? The light ray will be just coinciding with the normal. The light ray, coinciding with the surface. Okay, so the light ray, which is the refracted ray, will be just coinciding with the refracting surface. The refracting surface. Okay, so this particular angle is known as a critical angle. So see, and this is 90 degrees, which is the angle of refraction. The angle of refraction. Okay, so critical angle is that particular angle of incidence where the angle of refraction becomes 90 degrees, or at that particular angle of incidence, the refracted ray will be coinciding with the refracting surface, and which is also known as grazing. The refracted ray grazes the surface. Akhilesh, the refracted ray, what happens? Refracted ray grazes the surface. Okay. Okay, so this grazes the surface. Right. Okay, this is called critical angle. Now, the relation between the critical angle and the refractive index. The relation between the critical angle and the refracting surface. Okay, so refractive index. Keep the heading. Relation between critical angle and the refracting surface. That's a refractive index. Refracting index. Okay, so what is the relation between these two things? Ah, sine of angle of incidence by sine of angle of refraction. Look at this. Sine of angle of incidence. Here, sine get critical refraction. Get critical refraction. Sine of angle of incidence means C divided by sine of angle of refraction. Sine of angle of refraction 90 degrees. What will you get? Which medium's refractive index will you get? You will be getting the refractive index of air with respect to gas. I told you. Now, the medium which is just opposite to angle of incidence, that medium's refractive index you will get. Here, the angle of incidence is C, critical angle. The medium which is just opposite to that is air. Air refractive index you will get with respect to glass. Okay, so you will be getting the refractive index of air with respect to glass. Okay, but so this is sine C by this is sine 90 degrees is equal to 1 by refractive index of glass with respect to air. Okay, so I need refractive index of glass, not air. You know, refractive index of air is 1. Okay, so refractive index of glass with respect to air is equal to reciprocal of this fraction, sine 90 by sine C. Therefore, refractive index of glass with respect to air is equal to 1 by sine C. 1 by sine C. So that is the relation between the critical angle and the refractive index. The critical angle and the refractive index. But okay, so this again, based on this, we have so many applications, means so many problems and all of these we will have to do. Right? Now coming to total internal reflection. Total internal reflection. What do you mean by total internal reflection? Okay, so in the same discussion I can take it. So total internal reflection. Total internal reflection. So what do you mean by total internal reflection? This is what we have to know now. What do you mean by total internal reflection? Okay, so whenever the angle of incidence is more than the critical angle, yet the critical angle itself, the refracted ray is coinciding with the refracting surface. Now, if at all the angle is increased a little bit further, more, what happens then? So look at this. This is okay. The angle of incidence, so which is more than critical angle. Then for this light ray, there is no way, there is no possibility to enter into the air. Okay, so it will undergo reflection within the same. It will just undergo the reflection within the same medium. Within the same medium. That is total internal reflection. Total internal reflection. So we have got so many applications of this total internal reflection. What are they? In optical fiber, we will be using the same process, same phenomena. Okay, so in medical equipment like endoscopy, gastroscopy, okay, we will be using the same phenomenon. But the point, okay, like that we have so many applications of this total internal reflection. Total internal reflection. Come on, put it down. Yes, over. Understood? Understood? Okay. So based on this, I will give you one problem, conceptual problem. Swimmer or diver, because swimmer will be in on the surface now. A diver goes down. Okay, a diver. The person who dives. Okay, a diver looks at a diver is yet the bottom of a pool. Bottom of a pool. Okay, of depth. Okay. Yes. Okay. Calculates the area on the surface of water through which he sees the outside world. The refractive index of water with respect to air. Which is called absolute refractive index. Which is called absolute refractive index. It's looking very furious, man. Very furious. Nothing will happen. Huh? Nothing will happen. In the morning, at least Sachin Henderson, he covered his head with that towel, the cloth. Now there's a humidity removed. Huh? What is that? That's a cloth, towel, what is it called? Muffler? Muffler. Muffler is the laughing. Scarf. Scarf is different. Scarf is different, muffler is different. No need of laughing. Try to understand the meaning. Scarf means that is a piece of cloth which we use to cover. NCC people, scouts and guides, they will be having one blue cloth, that is a square-shaped cloth, but they fold it triangle they make. That triangular cloth, that's they put it here. One, what is it called? So white color, just like bead, big one, bowl, just like a bead. So that they put. Then, okay, that is called scarf. Sometimes even police people, officials, they will be having one cloth. That cloth is attached to cap. That is called a scarf. This is muffler. Muffler means it's a piece of cloth which is a rectangular shape, which we use to to cover our ears and head the portion from cold. From cold. Okay, like this. Yes. This problem, please. Yes. Answer, please. Yes. Answer. This much time. 640. 640. 640 square meters approximately, he says. 640 square meters, he says. Yes. What, Sachin, what do you say? Girls? In the problem, okay, it seems much data is not given, isn't it? Much data is not seen, but much only you have to find. 104, 104. 104.6 square meters. Another answer. Yes. Okay. Girls, what did you say? Calculator. Mahesh, sorry. Subha. Sapna. Your answers, please. Yes. Come on. Right. Any more answers? Akhilesh, what do you say here? 104. 104. Okay. Since the situation is just beside a few sir. Okay, different different results of people get anger. You fellow that you just sat beside me and you are telling how there you are giving it. That's a different answer. Okay, wait, we go outside. After going outside, I will see. Okay, here Sal is there. Yes. Okay. What a grace. No, not like that. Independent. You are independent. Good, very good. Yes, this 104 is supported by Akhilesh. But Mayur, what do you say? He did something, he completely erased. He did something, he completely erased. Pardon? 104, changing your idea, opinion? Okay. So, since Sagar is on the side of Sachin, Sagar also has changed up his mind. Why to get the headache and that's all this is just like a muffler. Okay, just like muffler. Urgent. Okay. Okay. Why to have this skill? Okay. Did you watch Allu Arjun's movies, sir? Did you watch them? Okay. So there are some movies in which his fightings and all things look very ferocious. Like this. When he says like this, balls and all this. He will be beating like anything. Okay. Yes or no? Some movies. Physics is not applied. Physics will not be applied in nowadays. You see, this here nowadays, the hero will be with you. He will be beating. After beating, okay, that fellow, the villain, like this, like just like dancing ball only. You ball also, like this, he will point like this. The moment he comes up, he will be hanging. Can you guess which movie is this? Can you guess? Mahesh Babu. Bharatan and Nehru. Okay, he will be hanging over here. So he becomes the CM. Okay, so there's a neat white shirt. Okay, the area where the fighting took place is very dirty. So that was one old cinema hall. Yes, sir. Okay, very dusty, but not even silver. Even that person will not. That will be very. Okay, but he will be. That fellow will be hanging like this. Okay, nowadays there is no physics in physics. No physics in physics. And you can't search for the physics laws behind the painting. Understood? Only animation. Only animation. Okay? Like this. Yes. Let's come to this. What is the answer? Mayur, what do you say? 104. Just behind me. Okay. So you will be only in your period, sir. Later we have to move with him. Later we have to move with him. You will not be there, no then. Okay, like that. Okay. Now look at this. So this I will solve this problem. Look at this. A diver is in the bottom of a pool of depth of 10 meters. So calculate the area on the surface, okay, of water through which he sees the outside world. Right? Now we can just get to see this is the hole. Okay, now the second you see this is water. This complete is water. This complete is water. Okay, so the depth is 10 meters. The depth is 10 meters. Right? Okay, now the second, the diver is here. Okay, and if at all he sees perfectly there is a normal perpendicular, then what are the white rays which are passing like this? So the diver will be able to see all these things. And if at all he sees the outside world like this, the white rays undergo refraction like this, away from the earth. But right, so the things which are present over here are visible to this diver. Next, if at all you see the outside world like this, even here the white ray undergoes refraction like this. Like this, as you keep on increasing the angle of incidence at a particular point, these white rays will be just coinciding with the surface. Then, what about the things which are present over here? So those things will not be visible to the diver. So this becomes okay. Then the white rays which are beyond that, the things will not be seen to the diver. Right? To that person, the things which are beyond that will not be visible. Will not be visible. Okay, so in that way, so you will be just getting a patch over here. You will be just getting a patch over here. Okay, so you will be getting just like a patch, circular patch on the surface. Now like this. In this way, right? So this is the possible area through which the diver can see the outside world. The diver can see the outside world. The diver can see the outside world. Okay, now in this particular case, this is area. A is equal to pi r square. So r we need to find out. So for this circular portion, this becomes r. Right? Now, what do we call this? And if at all you take this, so this becomes a critical angle. When this is a critical angle, what about this angle? You will send also alternate interior angles between the two parallel lines. Okay, so this is one line, this is one more line. Okay, these two lines are parallel. These two lines are parallel with each other. These two lines are parallel with each other. Okay, so this is some critical angle. This is a critical angle, right? Now, refractive index of water has been given with respect to air, so which is 4/3. Now, what is the relation between the critical angle and refractive index? So, refractive index of water with respect to air is equal to 1 by sin c. 1 by sin c. So, sin c in this particular case, 1 by refractive index of water with respect to air. Okay. So this is here 1 by 4 by 3. So which is 3 by 4? Which is 3 by 4. Okay, now this I want. This I know. It's given. So H is equal to 10 meters. Okay, so for this C, this becomes the opposite side. This becomes some adjacent sides. Okay, so opposite by adjacent, if you are to write, that is nothing but tan C. That is nothing but tan C. But tan C is how much? We need to find out. Sin C is equal to 3 by 4. Sin C is equal to 3 by 4. Okay, so if at all we take a right angle, which is right angle triangle, so this is C, this is 3, this is 4. Okay, now what will be the side? So this is 16 is equal to, you say x. So this is 9 plus x square. So x square is equal to how much? 7. Understood? So x is equal to root 7. X is equal to root 7. Root 7. Okay, root 7. Right. Okay. Now, tan C is equal to how much? So tan C, 3 by root 7 is equal to r by 10. R by 10. So that implies r is equal to 30 by root 7. So r has come. Area, which is pi r square. So pi r square, pi 22 by 7 into r square. Okay, 900 divided by 7. 900 divided by 7. Okay, so here, so this is 49. Right? Okay, so, okay, so into 100 by 49. 49. Okay, so let's divide this. 198, 49. So how many times? 4 times, 3 times? 4? Okay. Okay. Again 0, 0. Now again 4 times. 196, 4. Okay. So like this, 4.04 you will reach. 4.04 into 100. 404 square meters. 404 meters square. Okay. I got this one. I didn't tell outside. You see, in my figure that one 40. In my worker 404. Huh? Okay. Be careful, our city is there. So, even though our city is there inside, that it is not understanding. Huh? That was also today he kept it open. Morning he covered. He can cover. Okay. What, Jival? You want to say one side? Same thing, he's telling no. No, I have confidence that he would have done. Okay, that's fine. Okay. Right. Shall I sit down now? No need. Okay. Yes. So this is the way how we have to handle the problems, right? Now this is something about the critical angle and the relation between the critical angle and the refractive index. The refractive index, right? Now, one more thing we need to discuss, that is a normal shift. Already lateral shift is so lateral shift also we can discuss now. Lateral shift means that we come across the slab, glass slab. Okay, so keep the heading refraction by a glass slab. Refraction by slab. Refraction by a glass lamp. Refraction by a glass lamp. Okay, so what do you mean by refraction that takes place through a glass lamp? What do you mean by refraction that takes place by a glass lamp? Okay, so look at this. The actual 3D view of glass lamp can be shown like this. Like this. So there is a glass. Okay, so this side, this becomes one refracting surface. This complete becomes a second refracting surface. This is one refracting surface. And this becomes the second refracting surface. This becomes the second refracting surface. Okay, that becomes the second refracting surface. I will be placing one object over here. Right? Now, from this object, this is A. Glass slab, not hollow one. This is solid. That means from this surface to this surface completes. So glass is there. So glass solid. Right? Now the white ray is passing like this. On the surface here, the white ray is incident. In this direction, the light ray undergoes a refraction. This is a refracted ray. Again, the light ray undergoes refraction from this glass into the air. Then the refracted ray moves away from the normal. This is how the actual refraction takes place. This is how the actual refraction takes place through a glass slab. Through a glass slab. Understood? But like this, if we keep discussing, it looks very complicated. That's why, so to study this refraction, this is 3D view people don't get. Okay, so this we need to convert into 2D. Plane figure. Plane figure. Right? Okay, so that's how to convert this complete refracting surface as a line behind it. This complete refracting surface as a line behind it. Line. Okay, so this is the line one, which is the refracting surface. And so one more refracting surface we will take over here like this. Okay, so this is the refracting surface 1. So this is the refracting surface 2. This is the refracting surface 2. Okay, now in this particular case, what happens over here? So this is the source of light. Okay, so through the glass region, the light ray is passing like this. The light ray undergoes refraction over here like this. If at all you draw one perpendicular, which is called normal. Okay, so this is the first point of incidence, that is A. Right? This is point A. So this is the angle of incidence I. This is the angle of refraction R. Okay, so this is the second point of incidence, which is C. Next, draw a perpendicular over here like this. Okay, so these two things become parallel. So this angle and this angle become alternate interior angles which are same. When this is R, this becomes R. That means R can be taken as the angle of incidence for the second refraction. Okay, so this is the light ray which is obtained after having all these refractions. So this is called emergent ray. This is called emergent ray. Emergent ray. So this is incident ray. This is incident ray. And what is the light ray that we have taken? This is refracted ray. This is refracted ray. Incident ray, refracted ray, and emergent ray. Okay, so this becomes the angle of emergence, that is E. we can see that ultimately the emergent ray will be parallel with this incident ray. Emergent ray will be parallel with the incident ray. Got it? Okay. Now, so what is the angle of deviation? Look at this. Now you extend this one like this. From this usual propagation, light ray got bent over here. At what distance? Perpendicular distance. This is the perpendicular distance. And this is called the lateral deviation. So there is small d. Small d represents the lateral deviation. Lateral deviation. Okay, the thickness of the prism, so slab, that is a t, you say small t. In this case, to find out the refractive index, so refractive index of glass slab. So same formula you will be using, which is sin I by sin r. Sin I by sin r is applicable for refractive index. Okay, but for this lateral deviation, what is the formula? What is the formula? So look at this. Here you see, this is the straight line. This is the straight line. So when this is I, this complete I, this also becomes I. Can I get? Yes or no? Yes. Then this becomes what? I minus R. Understood? That becomes I minus R. Okay, now this is the right angle triangle. So what is that? This is AC and this is okay, capital D you say ACD. Triangle, from triangle ACD. From triangle ACD. From triangle ACD. So what do you notice? So sine I minus R is equal to, okay, opposite side which is d by hypotenuse, that is AC. Understood? But what is the value of AC? What is the value of AC? D is equal to AC into sine I minus R. Now the value of AC we need to calculate. In what way? Okay, so in the problem, the thickness of this glass slab will be given. There is T value in terms of centimeters or something. Okay, so now in terms of T, you need to represent. So for that purpose, I will be taking the triangle ABC. Triangle, from triangle ABC. From triangle ABC. From triangle ABC, what do you say? So AC value I want. Cos R. Cos R is equal to adjacent side which is a T by hypotenuse AC. So AC is equal to T by cos R. T by cos R. T will be given. Okay, so the angle of incidence will be given. By using this refractive index, you can calculate the angle R. By using Snell's law, sin I by sin R. Understood? Okay, so AC value substitute here. Therefore, lateral deviation T by cos R into sin I minus R. So this is what lateral deviation. That's what the lateral deviation is. That is what lateral deviation is. Come on, please make it fast. Yes. Hold on. So please make it first time. Now, this is called lateral shift. Okay, so in this refraction concept, one more practical application we come across in which we will be estimating the normal shift. We will be estimating the normal shift. Normal shift. Okay, so what do you mean by normal shift? Usually, the normal shift we will come across in the case of swimming pool. The bottom of the swimming pool appears to be rising. But the right, so there is called normal shift. Okay. So what is the formula for normal shift? What is the formula for normal shift? This is what we have to think of now. This is what we have to think of. Grace. Okay. Okay. Normal shift. Normal shift. Normal shift. Okay, so what is the formula for normal shift? What do you mean by normal shift? This is what we have to think of now. It is our common experience that if you don't go to swimming pool, okay, so directly this here swimming pool is there. So this is directly above, from above, so like this, if you see, then you will be getting the actual, because that becomes normal distance. There will be no deviation. Understood? So if you look at the bottom of the swimming pool, where water is clear water means even the bottom also is visible. Even the bottom is visible. Okay. So from some inclination, okay. So from the shore, from the bank, so when you look at the bottom, okay, how does the bottom appear? The bottom appears to be raised to some extent. Did you ever notice this? And you will be, so you may feel that the depth of the swimming pool, okay, is somewhat less. Now thinking like that, if you jump, the actual result will be something different. Are you getting? Okay. Yes or no? Okay. So for all those you know swimming and other things you can manage. And if at all you are new to swimming, finish. Okay. You will go and focus on becoming. Then the coach has to jump to save you. The coach, okay, so have to jump to rescue you. Am I correct or not? Okay, so the depth of the swimming pool appears to be less. Why? Because the bottom of the swimming pool appears to be rising. The bottom of the swimming pool appears to be rising. Okay, so here that is called normal shift. So look at this. How does this happen? So look at this here. You see, this is the swimming pool. Right? Now this is water. This is water. Okay. Right? Okay. Now you are looking at this point A. So this is the actual depth. Okay. So this is A and this is B. Okay. So what is AB? AB is actual depth. AB is actual depth. Actual depth. But this actual depth will not be seen if you look at from here. Okay, so this here like this. Up to here, dive board. This is a dive board is there. Imagine. Dive board. Okay, so there is a person who is standing up here. Okay? Okay, that person is going to die now. The person is that much the small and this much is it swimming pool or any oceans are there? Okay, any river. Okay, swimming pool only. Okay, big swimming. Big swimming pool. Okay, right. Now this person is looking at the bottom. Now what happens over here? From the bottom, the light ray has to come. The light ray has to pass through air. The light ray has to reach the eye of the person. Am I correct? Now look at this here. The light ray is coming like this. This normal. Okay, this is water. This is air. denser, rarer. When the light ray passes from denser to rarer, refracted ray will be moving away from the normal. Refracted ray will be moving away from the normal. Yes, okay, but this observer feels that this light ray seems to be coming from somewhere. For the observer, okay, this A seems to be here, there is dash. Got it? Okay, for the observer, A dash, this much part is missing. Understood? This much part is missing. The observer will feel that. You ask observer, how? What man? What is the depth? Depth is only A dash to B. That's all. Very simple. That's what he says. That's what he says. For observer, okay, so the bottom of the swimming pool appears to be here. So this is O and this is O dash. Understood? Okay, so the observer will feels that A dash B. So this is AB, which is actual depth. So A dash B, this is apparent. This is apparent depth. This is apparent depth. Right? Now the light is passing like this. And what is this? This becomes the angle of incidence. And what is this? This becomes the angle of refraction. Got it? Yes or no? Okay, now look at this here. There is a triangle over here. So this is O dash and this is C, you think. Okay, now look at the triangle AOC. Triangle AOC. In the triangle AOC, okay, so what is this? So I. So this is AO and this is A dash O dash. Okay, so tan I is equal to, okay, opposite by adjacent. What is that? AO by CO. Got it? Okay, so what is CO? CO means AB. Right? So this is tan I. AO by CO. CO means AB. CO means AB. Okay, but I is very small. Then tan I and sin I, both things will be equal, almost. Okay, so sin I is approximately taken as tan I. Therefore, in this particular case, sin I can be taken as AO by AB. Right? And in the same way, look at the triangle A dash O dash C. A dash O dash C. In this, what is this angle? R. Okay, this is R. Okay, so tan R. Adjacent side. Okay, so by opposite side. Opposite by adjacent. Opposite. A dash O dash by. Okay, C O dash. Okay, so tan R. A dash O dash will be what? AO. C O dash will be what? A dash B. Understood? But since R is too small, this tan R, sin R, both the things are taken as equivalent. So this can approximately be taken as a tan R. So sin R in this particular case, AO by A dash B. Now what I do is I will be taking Snell's law. Sin I by sin R. Sin I by sin R. Okay, so what is sin I? AO by AB divided by sin R is equal to AO by A dash B. These two things will get cancelled out. So that is equal to A dash B by AB. If I write sin I by sin R, what do I get? Refractive index of what with respect to what? Sure. You will be getting refractive index of A with respect to water. Again, you forgot. Sin I by sin R, if at all you write the medium which is opposite to I, you will be getting the medium which is opposite to I is air. Air refractive index you will get. Okay, but reciprocal principle of reversibility. So this A dash B by AB is equal to, okay, 1 by refractive index of water. Therefore, refractive index of water with respect to A is equal to how much? AB by A dash B. What is AB? Real depth. What is A dash B? Apparent depth. So, the refractive index in this particular case. Okay. So, refractive index is equal to real depth by apparent depth. Real depth by apparent depth. That's what refractive is. Okay. So the refractive index is equal to real depth by apparent depth. Real depth by apparent depth. Now shift unit calculate. First you write up to here. Yes. Okay. Next. Okay. Now this normal shift we need to take up. Normal shift. So what do you mean by normal shift of here? So look at this normal shift in the sense of what is the normal shift here in the diagram itself? Normal shift. This A got shifted here. Am I correct? So A dash B, this becomes normal shift. This becomes a normal shift. Okay. That is not A dash B. This got shifted here. No. This becomes normal shift. Okay, A dash. Normal shift. normal shift A dash is equal to AB minus A dash. Am I correct? AB minus A dash. So normal shift, there is a delta or D. Delta. AB is what? The actual delta minus apparent delta. Okay, so mu is equal to real depth by apparent depth. So apparent depth is equal to d by 2. This I will write over here. So delta. So normal shift. This is the formula that you will use. So in this case, the normal shift is d into 1 minus 1 by mu. 1 minus 1 by mu. So that is called normal shift. That is called normal shift. Okay, now the time is exactly 5. Now the time is exactly 5. Okay, now this is stop. Okay, so we will conclude the class, right? So there is a last topic we are talking in the chapter, which is lens. Lens makers formula. It won't take much time.